If you're responding to an incident response in a cloud environment, you want to make quick decisions on quickly identifying which are some of the rapid incident calls you can make. Now, in this video, I have Rich Mughal, who works for Securasys and also runs the popular CloudSlaw, which is a cloud security lab a week. Now, he's been training at Black Hat for incident response in cloud as well. So he was kind enough to create this video for Admin of Cloud Security. So you can also find this particular video of how to quickly respond to incident response at admin.cloudsecuritypodcast.tv as well. But for now, let's get into the video and understand how you can make some quick, rapid decisions if your incident response is using very cloud native services. Let's get into the video.
Wait, what? Another incident? Hey everyone, this is Rich again from Cloud Security Lab a Week, or CloudSlaw. And if you watched my last video, I went through and showed you that whole recipe picks process for doing incident analysis with a really simple incident. What I'm going to do this time is a little bit more of a complicated incident that's going to highlight not just the process, but give you guys some hints about kind of different things to look for when you're responding to an incident that's like really cloud native and more than just somebody making one single API call. So I got a little fancy on this one, and let's see what happens. First thing I'm going to do is I've got my trusty little iPad here, and it's running my command and control, and I'm going to go ahead and launch the attack. Okay, that was pretty quick. I got alerts right away. So you can see I've got some alerts flowing through. Sensitive ports exposed to the internet, and then that was my public snapshot. So this is my alert that's going to kind of narrow me down to give me a sense of what's going on here. And sensitive ports means like port 22. So we're going to go back over to our recipe picks. Now I still have my environment set up with my queries, tables, everything's running in that same environment there. So we'll go through this a little more quickly. But you're going to see that this is definitely a more complicated incident and how to piece it together. All right, so to start, I'm going to go ahead and pull that instance ID. And as with all of these, there's an alert that was triggered, and this is going to tell me where to start my response. Without a threat detector, you don't really have a good sense of what's going on there. Clicking back over, we'll go into our into AWS, and I'm going to do a couple of things, but the first thing I want to do is look at that resource itself to get a sense of how bad my exposure is. I'm going to open up another tab and go to EC2 and look at the instances. I'm going to filter for that instance. Okay. So looks like it's not even fully up and running yet. That thing was just launched. It does have a public IP address, so that's potentially concerning. And as I scroll through here, give me some information about this and the state of this resource. Remember, I'm just looking really quickly, just getting a sense of that resource. We're not doing any system forensics or anything at this point. A couple of things stand out to me. One is this has an IAM role, and I will run that down. It has a public IP address. We need to look at that. And let me scroll back up. Let's go ahead and look at security. And even though I got that alert that it was publicly exposed, this is telling me it wasn't publicly exposed. So that's a bit of a curiosity to figure out. Now, it could be because I have some other security controls in here to reverse it. So it looks like there's going to be some self-contained here, because if I look at the security group rules, it's all ports and all protocols from that default security group, but it's not actually, it's like trusting that other security group. It's not open to the internet. It does have full outbound internet access. So that is a bit potentially concerning, because that means it could, maybe there's something going on in there that's exfiltrating that data. All right. So that gives me the basics of that instance. And let's go into our query and start running down a little bit what's going on here. So if you recall, going back to recipe pick, so I figured out the resource, and I want to look at all the API calls on that particular resource. So going back over to my query here, and I'm going to swap in. If you watched my video yesterday, well, you might suspect I'm recording this one right after that one, because it's all the same stuff in all the same windows. And I'm going to look for any API call that is where it is either the request parameters or the response elements. So it's going to give me everything, have that instance in it. Well, let's hit run. And hopefully I didn't make any copy paste errors. All right. So there's a lot going on here, and let's interpret it. We've got 25 API calls, and I'll just tell you right now, these ones that I did, we're going to just kind of ignore. That's just me from clicking in the console. And these ones that say the StackSet DOps, the old name of the product was DisruptOps, I'm going to ignore those. The ones I care about is the app maintainer. Why? Because I know who this is and I know who this is. So I'm going to kind of eliminate them and see what's going on here. So going over, there's those request parameters, and let's just look at the event names. So I have a run instance, assume role. So that's a little bit concerning. Interesting. So that app read role, if you remember, the instance has that app read role. So that's that instance getting that role. Okay, so I know that role was definitely assigned and used, but of course I knew that when I looked at the instance in the first place. Then I've got describe instances. Now, just so you know, you'll see this pattern a lot where it's like run, describe, describe. The APIs, the SDKs will do that because they're constantly asking, are you running yet? Are you running yet? Are you running yet? So that's really normal to see a bunch of repetitive API calls like that. Then there's this assume role again for that app read role. And I am guessing there's no user. Yep. So this is just the basically, because I don't have an identity associated with it for who called it, it's part of the process of giving the instance that role. More of those describes. Now this gets interesting. Create image. I want to actually look at the entire API call here. And there's two interesting things I'm already seeing here. So instance ID. So remember the API call is create image. So the attacker created an image of this instance. All right. So that's concerning because that is another exfiltration technique similar to the technique that we used in our last one of making a snapshot public. The other thing is, I noticed as I was scrolling across, so this is the API call to run the instance. And I probably should have had you just read the whole thing in the beginning because look at this part right here. User data, sensitive data removed. Let's talk for a minute about the user data field. The user data field, it's actually one of my favorites for sneaking in attacks. And when I run this particular scenario in a training class, I usually will fool most of the students because they don't understand that they need to look for that. And if I had not had my full request parameters in the query, I wouldn't have picked this up. What is the user data field? If you're not familiar with it, when you launch an instance, and I think some containers support this, it's a way of passing data into that running instance. So code or whatever inside can go ahead and use that data that's been passed in. So we use it for passing in things like license codes and such. And that's why Amazon retracts it from the logs and mask it in the logs with that, sensitive data removed. Because frequently that's used to pass in usernames and passwords for things like databases that need to be connected to. It's not the right way to do things, but it is how people have been doing it for a while. I seriously don't ever do it this way. We have some labs over at CloudSlaw that show you why you don't want to do it this way, but it does exist. The other thing you can do with the user data field is if your instance has a little piece of software in it that many operating systems support called Cloud Init, it will actually run any commands that are put in. And there's different formats for it, but typically you can just pass in like a bash script. And then that bash script will run when the instance boots, but before you actually log in and do anything. So those are the two reasons we use the user data fields: to pass data into the instance or to run commands. Why would you need to run those commands? That's a really common way of configuring instances. In the early days of cloud, it was hard to build your own images. We didn't have the tools for automated pipelines to create your own images like we do today. And even today, I will still occasionally use Cloud Init to just kind of automatically configure some things when my instance runs. So that's why that capability was built. It's very, very useful, but like everything useful, it can be abused by adversaries. All right. So going back to where we are, and again, using the mnemonic, remembering the recipe picks, the events, the API calls on that resource. I pulled all the API calls on that resource, and I have a couple that are interesting. One is when they ran the instance, they gave it something in the user data field. They also assigned an IAM role. So I'm going to have to figure those pieces out. We're going to get there. And then the other part is they created an image of that instance. And that is, to me, potentially the kind of thing that I worry about for exfiltrating data. Now, the rest is pretty standard stuff. And so a lot of describe calls from looking at it in the console. Okay, so I'm starting to get a sense of this. Somebody ran an instance. They put something into the user data field. They also made an image of that instance. And if I was doing a real instance, this is like the stuff that I would write down in my notebook so I don't forget it. Well, what about the changes? Well, in this case, there are no changes because it's a new instance that was run. Now, we don't know what image it was based off of, and that's something we're going to look at as well pretty briefly. So, but it wasn't like they modified an existing resource. They didn't modify anything existing. Also, that's hard for me to demo because I don't have a change management tool running in this particular environment. I mean, I do, but we're not wired in to show that in this demo. So I know the API calls. I have a sense of what's been going on here. Now, I did mention I don't know what image that instance was based off of. That's one of the things that I always like to know as well. So I go back into the details on the instance. And again, we will get back to that IAM role. That's just part of our process. But okay, let's scroll down. There's the AMI. I'm going to open this up in a new tab. And so that image, there is nothing found. Now that's because I'm looking for public. So maybe that's just one that's owned by me. And sure enough, I have other images that are based off it. So why does this not show up in private images or anywhere else? Well, here's another little trick. And this one is one I threw into this scenario. It's actually hard to maintain it, but it's in there still. I'm not going to go through and do the command line of describe image. But if I did describe image, what you would see is that image is deprecated. Amazon ages out old images. You can still use them in your account if you own them. There's rules around that, but you can't like share them and they don't show up in any of the indexes. So in this particular case, I just know that if I don't have it showing up, like I can't figure out where that image came from, I could go to the command line and I could run like a Cloud Shell command. You know what? Let's go ahead and do that. So I'm going to go ahead and pause the video while I pull that up. Okay, I just went and pulled the data I needed. Let's see if I can paste this in as a command line. Yes. Oh, that's cool. That warning is new. Ask before pasting multi-line code. All right, we'll paste that in there and hit enter. And okay, so now I get a result. So I ran the query to describe the image. So you'll notice that if I go up here and I describe the image, that, whoops, we'll pull that image ID. Good, no password sitting in there anywhere. That nothing comes up. It comes up because it's an image. It's a copy basically of a different image. Nothing comes up as public if I search on that AMI ID. So nothing shows up anywhere. But if I run the command line, this is something you should need to know how to do, and I get a result. So let's scroll up and the image, run instance, and it's just based on something else. So there's not much to work with here. Let me hit enter again. Hit space to get the whole next page. And you can see this is Amazon Linux 2 AMI. So this is an old one from 2021 that Amazon deprecated out. And that's why it didn't show up in here. Why was that important? Because again, in terms of running down the resource, I now trace this. So I know the image that the attacker used is an old standard AMI that is published by Amazon, but it doesn't show up in the console. It will show up if you go ahead and you look for it directly. All right, going back. So I've figured out my resource. I've got the API calls on that. All right, now we're going to take a look at who did this. And if I go back into make sure I get the right name here, I have my app maintainer. So that is the origin. And I want to know who did that and what are their permissions. So pretty easy to trace back who did it because all the API calls are obvious. But let's go ahead and I don't need this tab anymore. So I'm going to just go to IAM. And by the way, everything again can be done from the command line. And I've got some scripts and things that are available to you in that blog post. And I'm going to go into users, and it's that app maintainer. And you saw that it was last used, access key was created today. That's disturbing. And no console access, but API access. Okay. What are the permissions? What is my identity blast radius of what this user could do? So I've got a policy attached to them, and oh crap. Well, right away, this is bad. This is a common combination for privilege escalation. IAM password with run instances. In fact, if you try and create a policy with these permissions together, and the other part is without any resource restrictions in the AWS console, Amazon will warn you that this is likely going to lead to privilege escalation. So I know now that that AMI is public as well because I also got that alert. All right, so we now have some problems going on here. What other API calls came from that IP address? I am going to skip this query. We showed it in the last video, and you know they're all coming from my VPN endpoint right now, which is where I'm running these labs from. What other API calls came from that calling identity? That's one we need to run. So we have our app maintainer. We're going to go back into our queries, and that was the IP address one. This is the app maintainer, and we'll see what else they did. And interesting. So here's some, other red flags. Get account authorization details. And did that work or not? I didn't record the response elements here, but here's another interesting query to run. So if we actually go to my cheat sheet, scroll down, I got to remember where it is in here, but I have this one. So there's a query down at the bottom here, which is designed to find any failed API calls. So let's go and add that in, do that as another query, because this is one of the things that can help you detect reconnaissance that's going on. I do need my table ID again. Let's swap that in and paste that there. And I'm going to get rid of these time stamps because I'm kind of doing everything all in one day here. Normally, you'd want to constrain that because if you just run that without constraints, you can get way too much back. But this is going to look for anything that was denied or unauthorized. Hit the run. Hopefully, I ordered by, event source and event name. Oh, but there's not even that many here. So you can actually see I got denied some billing information and some other stuff. And that app maintainer, I've got a couple denials. And it was denied get account authorization details and listing buckets. So it looks like they tried to get into the data with that permission and they couldn't. Remember that app read does give them access to all of the S3 buckets. And they're trying to get their account authorization details, which would give them a ton of information about the IAM and permissions within this account. All right, let's go back to the things that they did do, the API calls that they did make. And here's the big one. Remember I said you needed to have, you need to know what the IAM, the instance profile was. So they were looking at the instance profiles for a given role, which is probably how they nailed it. So they were looking around for roles, looking around at buckets. Some of this stuff got denied, some of it didn't get denied. And then the eventual thing that they were able to do after, look at this, they're trying to iterate through all the buckets. Nothing working here. They did a get caller identity, which is, hey, tell me who I am. So definitely those are things that if I see that and get account authorization details, I think compromised credentials. And then that run instance. And as we mentioned, the run instance and the create image, and then sharing that image, making that image public with the modify image attribute are the ones that, to me, are starting to tell me what happened in this particular attack. All right, so going back up into our process here, because we actually nailed down a big chunk of what we need to care about. Public, we did the IP address. I skipped that because it's all this IP address. Look for indications of a pivot. I have clear indications of a pivot. We know that they have that instance, but did they log into it? What were they able to do with that instance? And then why did they make that instance convert that to an image? Well, I have a couple of things that are a little suspicious here. And we haven't looked at that user data. And remember I said you could run commands, and that is a way to kind of run some automated attacks. So let's go take a look at that. Honestly, it's more frequently used for crypto mining than anything else. Now you'll notice if I scroll through here, it doesn't tell me the user data. It's a separate API call to pull that information. But in the console, if you go to Actions and Settings, and it's not show me the user data, you actually say edit the user data and it'll show it. And you know what? I think I know what happened here. Okay, of course I know what happened. I wrote this scenario. But you can see that the user inserted a bash script, listed a bunch of S3 buckets, and then it copied out one bucket name and into a local file. So this is what this means. AWS S3 copy that, everything in that bucket to that file. Well, this is the concerning point because they copied it locally, then they created an image, and then they shared that image externally. That combination is a real-world data exfiltration technique. Now, if you're a real Amazon expert, you know some of how I have this set up wouldn't work properly. All right, it's a little contrived, but it's just giving you the sense of what these attacks look like. But in this particular case, I feel like I've kind of narrowed down what's going on here. And I would do the long tail of the investigation, the forensics. I would actually look inside what's in that S3 bucket. I'd look to see, all right, well, they were creating the image. Did this command actually work? Were they able to create it? Although, again, it looks like they could copy that data out into that local system. But let's take it from the top. I got an alert first that some instances were public, and they weren't necessarily public. They had public outbound access, so maybe that's why it was triggered. Then I started my investigation based on that instance. That instance was a new instance, and that instance was run with this command in. It was assigned an IAM role that gave it access to everything in S3, and then the user data field ran a bash script that copied data out of S3 into that instance. Then the attacker, using the permissions they had, were able to create an image based on that instance and then share that image publicly. Or maybe in a real, most real exfiltrations, they share it with a specific individual account. Now, why did I run through this scenario? Because I wanted to show you a couple of things I didn't show you in the more basic scenario. One is how the attacker was able to escalate privileges and pivot to being able to do things with that IAM, from that IAM user into that IAM role. That's important to be able to track those traces. And really complex attacks can often have a lot of different pivot points as the attacker is exploring the different things in your environment. The other was showing you a bit about the user data field and how that is masked in the actual CloudTrail. And the only way to get it is to go into your live environment. Think about how this could be a problem if, for example, in your incident response, you terminated that instance before you got the user data. This has happened. I was helping a client 5-6 years ago with an incident, and they had actually terminated the instances that were involved in the incident, and they weren't able to access any of the metadata anymore. And if the user data field had been involved, they wouldn't be able to access that. Now, in their case, it ended up being okay. We had enough ancillary evidence to be able to figure out what happened, and it ended up not being a big deal, but that would be really bad. So that's why you always do containment, and you treat it like a real, as if you have a compromised laptop. You don't want to change anything on it until you investigate it. So now, what is the origin of this? Well, I do know it was that app maintainer IAM, and that was an IAM user. Those credentials were exposed somehow. That's when I hand off, like what IP address did it come from, some of the things we talked about in our last scenario. And then I would move from this mode right now into my containment and start locking everything down, pulling out those credentials, locking down those roles for the future. Everything, again, that I needed, I got almost all of it really quickly using the recipe picks mnemonic. I think it's a really good one. I mean, yeah, I wrote it, so of course I'm biased, but I think it does a really good job of helping us make sure we run through everything and we don't forget everything. And that's what these checklists are for. You don't have to do everything in the right order, but I'll tell you what, just yesterday I went flying and I did my pre-flight on the outside of the airplane without my checklist, but then I pulled it up and I went bang, bang, bang and made sure I checked all those boxes. We call it following a flow, and then you validate the flow with the checklist after the fact. Now, yesterday I didn't miss anything, but on a previous flight, I had actually gotten distracted and forgot to check the oil. And when I went to check that box, I'm like, oh yeah, I have to go back I actually didn't actually do that part. Not a cool mnemonic with that one. It's a checklist I have to look at, but the same concept is there. Anyway, I hope you enjoyed these 2 labs, giving you a little bit of insight in terms of how I like to investigate incidents in AWS. Really just a teaser of kind of how deep you can go with this stuff. If you have any questions, hit me up. You can reach me at Securosis. I'm also on Blue Sky as rmogul.com or at rmogul.com. And you can reach me at CloudSlaw at slaw.securosis.com. Thanks, everyone.